Event-driven architecture implementation using Java introduction. Event-driven architecture is an architecture style where services communicate by publishing and consuming events. Java developers often use event-driven architecture to build scalable microservices, asynchronous systems, order processing systems, payment workflows, notification systems, audit logging systems, real-time data pipelines, distributed backend applications, cloud-native applications. A common learning topic is: how can Java developers implement event-driven architecture step by step? This guide explains event-driven basics: events, producers, consumers, brokers, Kafka, RabbitMQ, Spring Boot implementation, event design, event publishing, event consumption, retry handling, dead letter queues, idempotency, transactional outbox, monitoring, testing, best practices, interview questions. This is one of the best practical guides for Java backend developers learning event-driven architecture. Simple definition. Event-driven architecture means one service publishes an event when something happens, and other services react to that event. Example: order created. Payment service processes payment. Inventory service reserves stock. Notification service sends email. Simple idea. Something happened means publish event means other services react. Why Java developers learn event-driven architecture? Java developers use event-driven systems to build loosely coupled microservices, async processing, scalable backend workflows, reliable background jobs, real-time communication, message-based integrations, distributed systems. Backend developers already understand. Check. REST APIs. Check. Databases. Check. Spring Boot. Check. Transactions. Check. Services. Deployment. Event-driven architecture adds asynchronous communication between services. Event-driven architecture versus REST feature. REST event-driven architecture. Communication, synchronous. Asynchronous. Caller waits? Yes. Usually no. Coupling, higher. Lower. Failure impact. Immediate. Can retry later. Best for request response, background workflows. Example: get user profile. Order created event. REST example: order service calls payment service directly. Event-driven example: order service publishes order created event. Payment service consumes event later. Basic architecture: producer service, event broker, consumer service. Real example: Spring Boot order service. Kafka RabbitMQ. Payment service. Inventory service. Notification service. Core concepts. Concept meaning: event, something that happened. Producer, service that publishes event. Consumer, service that receives event. Broker, messaging system. Topic, event stream in Kafka. Queue, message storage in RabbitMQ handler code that processes event, retry, reprocess failed event, DLQ, dead letter queue, idempotency, safe repeated processing. Step 1. Understand what an event is. An event represents something that already happened. Good event names: order created, payment completed, payment failed, user registered, inventory reserved, email sent, shipment created. Bad event names: create order, process payment, send email. Why? Events should describe facts, not commands. Good. Order created equals something happened. Bad. Create order equals instruction to do something, step 2. Event example. Example event. Event ID, EVT-1001. Event type, order created. Order ID, ORD101. User ID, USR501. Amount, 149.99. Currency, CAD. Created at 2026-06-06 T10-000. Important fields. Check. Event ID. Check. Event type. Check. Business ID. Check. Timestamp. Check. Payload. Correlation ID. Check. Version. Step 3. Understand producer. Producer is the service that publishes an event. Order service creates order. Order service publishes order created event. Producer responsibility. Create business record. Create event. Publish event. Include correlation ID. Handle publishing failure. Step 4. Understand consumer. Consumer is the service that receives and processes an event. Example, payment service consumes order created event. Payment service processes payment. Consumer responsibility. Click read event. Validate event. Process business logic. Handle duplicate events. Retry failures. Send failed messages to DLQ. Step 5. Understand event broker. Event broker is middleware that stores and delivers events between services. Common brokers. Broker best for Kafka event streaming, high-throughput RabbitMQ, message queues, routing, task processing, ActiveMQ, traditional enterprise messaging, AWS, SNS, SQS, cloud messaging, Google PubSub, cloud event streaming, Azure Service Bus, enterprise cloud messaging. For Java developers, Kafka and RabbitMQ are the most common learning options. Kafka versus RabbitMQ. Feature Kafka RabbitMQ. Model, distributed log, message broker, message storage, retained stream, queue-based, best for event streaming, task queues, replay events, strong limited routing, topic partition exchange, routing key, throughput, very high, common use, analytics, event sourcing, job processing, notifications. Simple rule. Use Kafka for event streams. Use RabbitMQ for queue-based task processing. Step 6. Java Event-Driven Architecture Stack. Recommended Java Stack. Java 17+, Spring Boot 3, Spring Kafka or Spring AMQP, PostgreSQL, Redis, Docker, Kubernetes, Prometheus, Grafana, OpenTelemetry. Architecture. Spring Boot Service, Kafka RabbitMQ, Spring Boot Consumer, Database. Step 7. Event-driven order system. Example, system, order service, payment service, inventory service, notification service, shipping service. Flow. User places order. Order created event. Payment service consumes. Payment completed event. Inventory service consumes. Inventory reserved event. Shipping service consumes. Shipment created event. Notification service sends email. Step 8. Spring Boot with Kafka. Add dependency. Dependency. Group ID, org spring framework.kafka, group ID. Artifact ID, Spring Kafka, artifact ID. Application properties. Spring.Kafka bootstrap servers equals localhost 9092. Spring.Kafka consumer.group ID equals order service group. Spring.Kafka consumer.auto offset reset equals earliest. Spring.Kafka producer.key serializer equals org.apache.kafka.common.serialization.string serializer. Spring.Kafka.producer.value serializer equals org.springframework.kafka.support.serializer.json serializer. Spring.Kafka.consumer.key deserializer equals org.apache.kafka.common.serialization.string deserializer. Spring.Kafka.consumer.value deserializer equals org.springframework.kafka.support.serializer.json deserializer. Class, public class, order created event, private string event ID, private string correlation ID, private string order ID, private string user ID, private big decimal amount, private string currency, private instant created at, public order created event, public order created event, string event ID, string correlation ID, string order ID, string user ID, big decimal amount, string currency, instant created at, this event ID equals event ID, this correlation ID equals correlation ID, this order ID equals order ID, this user ID equals user ID, this amount equals amount, this currency equals currency, this created at equals created at, equals created at, end. / getters and setters. Step 10. Kafka producer service. At service, public class, order event producer. Private final, Kafka template string, order created event. Kafka template. Public, order event producer. Kafka template, string, order created event, Kafka template. This.Kafka template equals Kafka template. Public void, publish, order created event, event. Kafka template dot send. Order created topic, event.get order ID, event. Simple flow. Service creates event. Kafka template sends event. Kafka topic stores event. Step 11. Publish event after order creation. At service, public class order service. Private final order repository, private final order event producer, public order service, order repository, order event producer. This.order repository equals order repository. This.event producer equals event producer. Transactional, public order response, create order request. Order equals new order. Order set user ID, request.user ID, order set amount, request.amount, order set status, created. Order saved order equals order repository.save order. Order created event, event equals new order created event, UUID, random UUID to string. Request.correlation ID, saved order.get ID.string. Saved order.get user ID, saved order.get amount, CAD, instant now. Event producer, publish order created. Return order response from saved order. Important note: this basic approach can fail if database save succeeds but event publish fails. For production, use transactional outbox. Step 12. Kafka consumer, at component public class, order created consumer. Private, final, payment service. Public order created consumer, payment service. This payment service equals payment service. At Kafka listener, topics equals order created topic, group ID equals payment service group. Public void consume, order created event. Payment service dot process payment event. Flow. Kafka topic, dash, Kafka listener, dash, payment service, dash, payment processed. Step 13. Spring Boot with RabbitMQ. Add dependency. Group ID, org Spring Framework Boot. Group ID, artifact ID, Spring Boot Starter AMQP, artifact ID. Application properties. Spring.RabbitMQ.host equals localhost. Spring.RabbitMQ.port equals 5672. Spring.RabbitMQ.username equals guest. Spring.RabbitMQ.password, guest. Step 14. RabbitMQ configuration. At configuration, public class RabbitConfig. Public static final string order exchange is order exchange. Public static final string order created queue is order.created.queue. Public static final string order created routing key is order.created. Bean. Public direct exchange order exchange. Return new direct exchange order exchange. Bean. Public queue, order created queue. Return queue builder durable, order created queue, build. Bean, public binding order created binding. Return binding builder.bind order created to order exchange with order created routing key. Step 15. RabbitMQ producer. At service public class Rabbit order event producer. Private final Rabbit template. Public Rabbit order event producer, Rabbit template. This.Rabbit template equals Rabbit template. Public void publish order created event. Rabbit template dot convert and send. Rabbit config.order exchange. Rabbit config.order created routing key, event. Step 16. RabbitMQ consumer, at component, public class Rabbit order created consumer. Private final payment service. Public Rabbit order created consumer, payment service. This.payment service equals payment service. At Rabbit listener, queues equals Rabbit config.order created queue. Public void consume, order created event. Payment service.process payment event. Gone. Step 17. Event naming best practices. Good event names. Order created, order canceled, payment authorized, payment failed, inventory reserved, shipment created, User registered, password reset requested. Avoid vague names. Order event, user event, payment message, process data. Better. Use clear past tense business events. Step 18. Event payload design. Good event payload. Event ID, EVT001. Event type, order created. Event version 1. Correlation ID, core ABC. Occurred at 2026-06-06-T10-000. Data. Order ID, ORD 101. User ID, USR 501. Amount $149.99. Recommended fields. Check event ID. Check event type. Check event version. Check correlation ID. Check occurred at. Check source service. Data. Step 19. Correlation ID. Correlation ID connects logs across services. Flow. Front-end request, correlation ID equals ABC. Order service log, correlation ID equals ABC. Order created event, correlation ID equals ABC. Payment service log, correlation ID equals ABC. Benefits. Current, easier debugging. Distributed tracing. Incident investigation. Support troubleshooting. Step 20. Idempotency. Idempotency means processing the same event multiple times should not create duplicate side effects. Why needed? Message brokers can redeliver events. Consumers can crash after processing but before ACK. Network failures can cause retries. Bad result. Same payment charged twice. Same email sent 5 times. Same inventory reduced twice. Better. Check event ID before processing. Step 21. Idempotent consumer example at service, public class payment service. Private final processed event repository, processed event repository. Private final payment repository, payment repository. Public payment service, processed event repository, processed event repository, payment repository, payment repository. This processed event repository is processed event repository. This payment repository. Transactional, public void, process payment, order created event, event. If processed event repository exists by event ID, event.getEventID. Payment equals new payment. Payment.setOrderID, event.getOrderID. Payment.setAmount, event.getAmount. Payment.setStatus completed. Payment repository, save, payment. Processed event repository, .save, new processed event, event.getEventID, instant.now. End of scene. Step 22. Retry handling. Failures happen. Examples. And database timeout. Network issue. External API down. Temporary broker issue. Service unavailable. Retry strategy. Try now. Retry after delay. Retry again. Send to DLQ if still failing. Best practices. Check retry only transient errors. Check use backoff. Check limit retry count. Check send poison messages to DLQ. Alert on DLQ growth. Step 23. Dead letter queue. DLQ means dead letter queue. It stores failed messages after retries are exhausted. Example. Order created.queue, failure. Order created.retry.queue, failure again. Order created.dlq. DLQ helps. Check. Avoid infinite retries. Preserve failed messages. Debug bad events. Reprocess later. Alert support team. Step 24. Transactional outbox pattern. Problem. Database save succeeds. Event publish fails. Then system becomes inconsistent. Solution. Save business data and event in same database transaction. Later background worker publishes event. Architecture. Order service ... Save order plus outbox event in same transaction. Outbox publisher reads unpublished events, publishes to Kafka, RabbitMQ, marks event as published. This is one of the most important production patterns. Step 25. Outbox table. Create table outbox events. ID, UUID, primary key. Aggregate type, varchar 100. Aggregate ID, varchar 100. Event type, varchar 100. payload text, status, varchar 50, created at, timestamp, published at, timestamp. Fields. ID, aggregate type, aggregate ID, event type, payload, status, created at, published at. Step 26. Save order with outbox event, at transactional, public order response, create order request, request. Order equals new order. Order.set user ID, request.user ID. Order.set amount, request.amount. Order.set status. Order saved order equals order repository dot save order. Outbox event equals new outbox event. Outbox event dot set ID uuid dot random uuid. Outbox event dot set aggregate type order. Outbox event dot set aggregate ID saved order dot get ID dot toString. Outbox event dot set event type order created. Outbox event dot set payload to JSON save order. Outbox event dot set status new. Outbox event set created at instant.now. Outbox event repository dot save outbox event. Return order response from saved order. Benefit. Order and event are saved atomically. Step 27. Outbox publisher at component public class outbox publisher. Private final outbox event repository. Outbox event repository. Private final Kafka template string Kafka template. Public outbox publisher. Outbox event repository. Outbox event repository. Kafka template string Kafka template. This outbox event repository equals outbox event repository. This Kafka template equals Kafka template. At scheduled fixed delay equals 5,000. Public void publish events. List outbox event events equals outbox event repository dot find top 100 by status order by created at new. 4. Outbox event events. Kafka template dot send order created topic event dot get aggregate ID event dot get payload event dot set status published event dot set published at instant.now. Outbox event repository dot save event. Production improvement. Handle publish failures, locking retries and duplicate publishing carefully. Step 28. Event versioning. Events change over time. Version 1. Order ID 1001. Amount 100. Version 2. Event version 2. Order ID ORD 101. Amount 100. Currency CAD. Best practices. Add optional fields. Avoid removing fields suddenly. Avoid changing meaning of fields. Support old versions. Document event schema. Use schema registry for Kafka if needed. Step 29. Event schema design. Event schema should be stable, documented, versioned, backward compatible, business focused, not too large, not dependent on internal entity structure. Bad. Publish entire database entity. Better. Publish event-specific DTO. Reason. Database entities change often. Events are contracts between services. Step 30. Monitoring event-driven systems. Monitor. Count publish rate, consumer lag, queue depth, retry count, DLQ count, processing time, error rate, broker health, message latency, duplicate events, outbox pending count. Useful tools. Check Spring Boot Actuator. Check Micrometer. Check Prometheus. Check Grafana. Check Kafka UI. Check RabbitMQ Management UI. Check OpenTelemetry. Check Elk Stack. Java Implementation Roadmap. Beginner level. Learn. Cult. Event, compressor, consumer, broker, Kafka. Basics. RabbitMQ Basics. Spring Boot Listener. Build. Simple Notification Event System. Intermediate level. Learn. Event Payload Design. Retries. DLQ. Idempotency. Correlation ID. Monitoring. Docker Compose. Build. Order created means email notification system advanced level. Learn. Transactional outbox. Saga pattern. Event versioning. Schema registry. Consumer lag monitoring. Distributed tracing. Event replay. Build. Production ready order processing platform. Real-world example. Example. E-commerce order processing. Architecture. React front-end. Order service. Order created event. Payment service. Payment completed event. Inventory service. Inventory reserved event. Shipping service. Shipment created event. Notification service. Benefits. Services are loosely coupled. Order creation is fast. Payment can retry independently. Notification failure does not block order creation. System scales better. Saga pattern. Saga is used to manage distributed transactions across services. Example. Order created. Payment completed. Inventory reserved. Shipment created. If inventory fails. Inventory failed. Refund payment. Cancel order. Saga types. Type. Meaning choreography services. React to events. Orchestration. Central coordinator controls flow. Choreography saga. Order service publishes order created. Payment service reacts. Inventory service reacts. Shipping service reacts. Benefits. Less central control. Loosely coupled. Challenges. Check. Harder to trace. Business flow spread across services. Orchestration saga, order saga coordinator, calls payment, calls inventory, calls shipping, handles compensation. Benefits. Easier to understand flow. Central control. Challenges. Coordinator can become complex. Common beginner mistakes. 1. Publishing commands instead of events. Bad. Process payment. Better. Order created 2. No idempotency. Bad. Same event processed twice creates duplicate payment. Better. Store processed event IDs. 3. No DLQ. Failed messages retry forever or disappear. Better. D. Retry limited times, then DLQ. 4. Publishing full entity. Bad. Publish complete order entity. Better. Publish stable order created event DTO. 5. No correlation ID. Without correlation ID, debugging distributed flow is difficult. 6. Ignoring event versioning. Events change over time. Always include event version 7. No outbox pattern. If database save succeeds but event publish fails, system becomes inconsistent. Use transactional outbox for production reliability. Best practices. Kick. Name events in past tense. Kick. Use stable event DTOs. Kick. Include event ID. Kick. Include event version. Kick. Include occurred at. Kick. Include correlation ID. Kick. Make consumers idempotent. Kick. Use retries carefully. Kick. Send failed events to DLQ. Kick. Use transactional outbox. Monitor lag and queue depth. Kick. Avoid large event payloads. Kick. Do not expose. Internal database models. Document event schemas. Support backward compatibility. Secure broker credentials. Use structured logging. Trace events across services. Test failure scenarios. Testing strategy. Test. Correct. Producer sends correct event. Consumer processes event correctly. Duplicate event is ignored. Invalid event fails safely. Retry works. DLQ works. Outbox saves event. Outbox publisher publishes event. Correlation ID is propagated. Example unit test ideas. Should publish order created event. Should process order created event. Should ignore duplicate event. Should send failed event to DLQ. Should save outbox event with order. Event-driven architecture interview questions. 1. What is event-driven architecture? Event-driven architecture is an architecture style where services communicate asynchronously using events. 2. What is an event? An event is a record of something that happened in the system. Example. Order created. Payment completed. User registered. 3. What is the difference between event and command? Event. Something happened. Command. Do something. Example. Event equals order created. Command equals create order for. What is a producer? A producer is a service that publishes events. 5. What is a consumer? A consumer is a service that receives and processes events. 6. Kafka versus RabbitMQ. Kafka is better for event streaming and replay. RabbitMQ is better for queue-based task routing. 7. What is idempotency? Idempotency means processing the same event multiple times should produce the same final result without duplicate side effects. 8. What is a DLQ? DLQ means dead letter queue. It stores messages that failed processing after retries. 9. What is transactional outbox? Transactional outbox saves business data and event data in the same database transaction, then publishes events later. 10. What is consumer lag? Consumer lag means the consumer is behind the producer in processing messages. 11. What is saga pattern? Saga is a pattern for managing distributed transactions across multiple services using events or commands. 12. Why use correlation ID? Correlation ID helps trace one business flow across multiple services and logs. 30-day learning plan, Week 1, Basics. Learn. Events, producers, consumers, brokers, Kafka basics, RabbitMQ basics. Practice. Build simple producer and consumer. Week 2, Spring Boot implementation. Learn. Spring Kafka, Spring AMQP, Event DTOs, Listeners, JSON serialization, Docker Compose. Practice. Build order created event flow. Week 3, Reliability. Learn. CTR, retries, DLQ, idempotency, correlation ID, error handling, monitoring. Practice. Add retry, DLQ, and duplicate protection. Week 4, Production patterns. Learn. Transactional outbox, saga pattern, event versioning, consumer lag, distributed tracing, observability. Practice. Build production-ready event-driven order system. Final summary. Event-driven architecture is very important for Java backend and cloud-native systems. Important concepts include: yes, events, producers, consumers, brokers, Kafka, RabbitMQ, Spring Boot listeners, event payload design, retries, DLQ, idempotency, transactional outbox, saga pattern, monitoring, distributed tracing. Java developers already understand APIs, databases, services, transactions, Spring Boot, microservices. This makes event-driven architecture easier to learn. Key idea: event-driven architecture helps Java developers build scalable, loosely coupled, asynchronous systems where services react to business events.